This is my 7th video lesson for Unit 9. In this lesson, we'll be analyzing applications and stability of radioisotopes. Go to page 33 in the class packet. Learning target. At the end of the lesson, I'll be able to identify applications and risks of radioisotopes and analyze why radioisotopes are unstable. Homework be number 7, which will be a Junipod based on this lesson. There will be a quiz Junipod on PowerPoints 5, 6, and 7. The exam will be on Unit 9 only. There are several applications of radioisotope. The first application is a tracer. Tracers are used in medicine to track chemical or biological processes. Since some radioisotopes can be detected, we can trace or follow the radioisotope when it enters the body. Another application of radioisotope is dating, which is determining the age of something based on its half-life. We covered this in the previous lesson. Another application is medical treatment. It is used to treat cancer. Another application is energy. For example, here is a nuclear power plant. The fifth application is killing bacteria. It is used to sterilize food and tools. The sixth application of radioisotope is weapons. Here is an example of atomic and hydrogen bomb. Here are some tips for the Regents exam regarding applications of radioisotopes. Tip number 1, look at table N to look at the half-life of the radioisotope if it's about radiometric dating. Can the radioisotope date the object or thing? Is its half-life long enough? Another possible question is exposure. Being exposed to radioisotopes for medicine or safety, the half-life of the radioisotope must be short. If the half-life of the radioisotope is too long, it will be dangerous for people. The second tip is about risk involving radioisotopes. The first risk is that exposure can cause cancer or mutation. The second risk involves storage of radioactive waste from nuclear power plants. The radioactive waste typically have long half-lives. Fusion has no radioactive waste compared to fission. The third risk is contamination of radioisotopes in the environment. Learning check number 1. Which phrase describes the risk of using radioisotope CO60 in treating cancer? Pause the video and resume once completed. The answer is choice 3. Increased biological exposure. To treat cancer, you must be exposed to the radioisotope. Learning check number 2. The ratio of the mass of U-238 to the mass of Pb-206 can be used to what? Pause the video and resume once completed. So you have to look up the half-life of U-238 in table N in your reference table. U-238 have a half-life of billions of years. Then you look at your answer choices and think what can your radioisotope do? Since the half-life is billions of years, it can date geological formation. The answer is choice 3. Learning check number 3. Which type of reaction produces energy and intensely radioactive waste products? Pause the video and resume as completed. The answer is choice 2, fission of uranium. Fission produces radioactive waste. Fusion does not. Here's a table of radioisotopes and their application that was asked on the Regents exam before. If it's higher up on the table, it was asked the most. The ones that are bolded are more likely to be asked than the ones that are not. Now we're going to talk about stability of isotopes. The larger or more massive a nucleus is, the harder it is for the nucleus to remain intact. When a nucleus is radioactive, it gives off decay particles and changes from one element into another. This process is also known as radioactive decay or natural transmutation. Atoms with an atomic number of 1 through 83 have at least one stable, non-radioactive isotope, but all isotopes starting with atomic number 84 or greater are radioactive, which is unstable. Here are the rules for stability. The first rule is that isotopes with atomic number greater than 83 are unstable, which means they're radioactive. The second rule is that isotopes with atomic number less than 83 are determined by the neutron and proton ratio. If the atomic number is less than 20, that means small elements, the stable ratio of neutron and proton is 1 to 1. If the atomic number is between 82 and 20, the stable ratio of neutron and proton is 1.5 to 1. Check of understanding number 1. What is the stability of isotope dependent on? is dependent on the proton and neutron ratio. Check understanding number 2. What happens when an atom have an unstable nucleus? It will spontaneously decay. Check of understanding number 3. What holds a nucleus together? It is the strong nuclear force. Check of understanding number 4. Why do larger atoms need a higher neutron and proton ratio to be stable? Because more neutrons are needed to increase the space between the protons. We're now going to analyze this graph. On the x-axis is the number of protons or atomic number. On the y-axis is the number of neutrons. This purple line represents protons equals neutrons. This yellow band is the band of stability. Isotopes in this band is stable. That means they're not radioactive. Isotopes not in the band are unstable. That means they're radioactive. There are two unstable regions. Isotopes in region A will undergo beta emission. Isotopes in region B will undergo electron capture or positron emission. Here's another version of the graph. The red line represents the band of stability. Depending on where your radioisotope is on this graph, you can predict what type of radioactive decay is going to undergo. Learning check number 4. For most atoms with atomic number less than 20, nuclear stability occurs when the ratio of the neutrons to protons is 1 to 1. Which of the following atoms would be most likely to have an unstable nucleus? Pause the video and resume as completed. The answer is choice 3 because the proton and neutron ratio is not 1 to 1. This concludes the video lesson. Remember to do the Juniper homework and quiz.